Hi friends, welcome to Arnav. Today is the 20th episode in the science series. So today in science it is physics. Yes. So today we are going to discuss about the thing that is the reason why we are standing on the ground instead of there. Yes. So that's the reason we are not flying or floating out into space, and that's the reason why birds are flying. Yes. So this is gravity. Yes. So in physics, gravity is a fundamental attraction which causes mutual attraction between all things with mass and energy. So everything with mass and energy will be attracted by gravity. For example, we also have gravity, but in a very small level. So in a very small level, I am somehow attracted to that bird. Yes. I am attracted to the bird.
Mass increases, gravity increases.
If the mass increases, the gravity also increases. Yes. So gravity comes from the Latin word which is gravitas, which means weight. Yes. So weight is very important in gravity. Yes. So gravity is by far the weakest of all four fundamental interactions. Yes, there are four fundamental interactions. There are gravity, strong interaction, electromagnetic force, and weak interaction. So it is 10 to the power of 38 times weaker than the strong interaction. Yes, that is 1 followed by 38 zeros. Yes, next 10 to the power of 36 times weaker than the electromagnetic force. Yes, gravity is that much times weaker than electromagnetic force, and 10 to the power of 29 times weaker than the weak interaction. Yes, with the weak interaction. So gravity is technically the weak interaction, not this. Yes. So as a result, it has no significant influence at the level of subatomic particles, while the electromagnetic force will change electrons like those. But gravity doesn't have significant influence on those things.
What are subatomic particles?
So subatomic particles are like atoms and their smaller things. Yes, like protons, electrons, like those. Yes. So, however, gravity is the most significant interaction between objects at the macroscopic, that means a big scale, and it determines the motion of planets, stars, galaxies, and even light. Yes, light. So, if you saw a black hole, that means a black hole in some image, so around it there would be light. So, that is the light, that light would be driven into the black hole because of the black hole's very powerful gravity. So for example, wait a second. Okay, so let's erase the part of this. Okay, so for example, this is a small black hole, so light would be around it. Yes, so this is light. So its gravity is so powerful that when light is just randomly going, the gravity will attract the light to the black hole. So then that light will join the thousands of particles which are floating there, going into the black hole and never coming out again ever. Yes. So yeah. Okay. And also the motion of planets is because of this gravity. So we are going around the sun because of this gravity only. Yes. So So Earth's gravity gives weight to physical objects, and the moon's gravity causes tides in the ocean. Yes. So again we must erase this. Okay. So the Earth's gravity gives weight. So because of the Earth's gravity, we have weights. So for example, one person is 43 kilograms, but if they are like another planet, their weight will be less. So gravity will change the person's weight. The mass would be same, but the weight would differ. So for example, if the gravity is low, the weight would be low. But for example, if we suddenly went to Jupiter for some reason, there would be lots of gravity. So then we would be very heavy. Yes, yeah. So that is a help of gravity. And also, moon's gravity causes tides in the oceans. So for example, this is our beautiful Earth. So here is our moon going around it. So the area where the moon is, there would be higher tides. There would be higher tides. While here there would be less tides. Yes. So if the sun is also here, these tides will increase a bit because the sun also helps in that. Yes. So yeah. Okay. Gravity also has many important biological functions, like helping to guide the growth of plants through the process which is known as gravitropism. Yes. So, and influencing the circulation of fluids in multicellular organisms like us. So it influences the circulation of the fluids in our bodies and animals' bodies. These fluids include lymph, blood, and other fluids in our body. Yes. Okay. So gravity may play a role in the immune system function and cell differentiation within the human body. So gravity also plays a role in the immune system function. The immune system, the system of our body which protects us. Yes. So gravity has a great influence. Yes. So in ancient world, a number of great people tried to describe about gravity. So these people include Aristotle, Archimedes, who are from Greece, next Aryabhatta and Brahmagupta from India, and Al-Biruni from Persia. Yes. So the gravitational attraction between the original gaseous matter in the universe allowed it to coalesce and form stars. So if you don't know what coalesce means, I'll show you. Okay, so for example, there are 3 water droplets here. Okay, so if someone push them closer to a middle center, they will not only be 3 but just one bigger huge droplet. So that is what coalesce means. That is the process of that. So when the universe was very early, finally the heat decreased, so gases can come closer to each other. So they came closer, then closer. It took millions of years, but finally they came closer for a star. Yes, so these stars are like our suns and others. Yes. Okay, so that's what coalesce means, if you don't know. Okay. So which eventually condensed into galaxies. So these stars turned into galaxies finally. Yes. So for example, this is one of that old big droplet. So finally lots of them formed. So many formed that they became a big like a group of these droplets, so like a galaxy and stars, their relation. Yes, so like that. So gravity is responsible for many of the logical structures in the universe, like the galaxies. Yes, so gravity has an infinite range. Yes, although its effects become weaker as objects get farther away. For example, here is our Earth. So a planet from the opposite of our whole universe, not even a planet but even a small piece of dust, can be influencing our Earth. But its influence is so small that we can't feel any of it. It's like there's not even a bit of influence at all. Yes, it is like infinite zeros and finally 1. Yes. Yes, so that's a very small influence. But the sun gives a bigger influence, so we go around the sun instead of our planet going to that small piece of dust. Yes. Yeah. So gravity is most accurately described by the general theory of relativity proposed by Albert Einstein in the year 1915. Yes. So which describes gravity not as a force but a curvature of space and time. So this theory says that so this is the plane of existence, or which actual name is time, space time. Yes. So for example, there's a planet here, not here but here. It will not just stay like this. So a bulge will appear. So a bulge like this. So okay, so but then if another thing came like a new moon to that planet, then it would just rotate around that bulge. So if you ever saw sinks, when water will come, so then it will rotate until the center. Yes, so that is a bit of comparison. Yes, so there would be hole here. So this, if the orbit is not perfect, so this will come here. Yes, so that is the theory of relativity. And when Isaac Newton said about gravity, he thought of it as a force, not a curvature of space-time. He saw it as a force. Yes, so the most extreme example of this curvature of space-time is a black hole. Yes, so from which nothing, not even light, can escape. Yes, as the example which I showed you earlier, light, not even light can escape it. The fastest object in the entire universe will just go into the black hole. Yes, so yeah, this is for today about gravity, the reason why we are still on the ground instead of just flying in the air and floating. So, and the reason why this dropped. Yes, so yeah, this is for today about gravity. Bye.